This question, we have two blocks. The string is negligible mass. It's vertically over a pulley of negligible mass, creating an Atwood's machine. They're initially at rest, so we know V0 equals 0. Y has greater mass than object X. So this thing is at rest, it's released, and since object Y has a greater mass, the system is going to accelerate like so. Because this mass is not large enough to equal this mass. If they were equal, there'd be no acceleration, but since this is greater, it accelerates. How does the gravitational potential energy of the XY Earth system change? Well, so the first thing we need to realize is that there's a certain amount of gravitational potential energy that Y has and X has. Once we release it, the system is going to accelerate. So there is going to be an increase in kinetic energy. And that kinetic energy is going to come from the gravitational potential energy. So gravitational potential energy will be converted to kinetic energy. So what we would expect to happen is the gravitational potential energy would decrease. That's the first thing. So when we look at the choices, we have gravitational potential energy increase, increase, decrease, decrease. So right off the bat, by just recognizing that the gravitational potential energy will decrease, gets us to 50-50. Now the next question has to, the second clause of each of these statements has to do with the center of mass of X and Y. And the difference is whether it moves upward or downward. Well, intuitively, it may seem like the center of mass must be moving downward. Remember, we can take any system and treat two bodies as if they're one. And combine them as if they're one. So if we take these two objects, and let's say this is the center of mass of this one, and this is the center of mass of that one, and we connect them by a straight line. And let's just suppose that this has a mass of m, and this has a mass of 3m. This would be the midpoint. So if they were equal in mass, that's where the center of mass would be. But since in this system that has a total mass of 4m, 3m plus m, then the center of mass would be 3/4 of the way closer to this object, so to the larger object. So this is where the center of mass would be. Now, if we were to wait and observe this thing to fall, we now have this body. Let's say it's had enough time to fall from there to here. The other body will have risen by the same amount that the X will have risen by the same amount as Y. And its center of mass would be up here, like so. And if we connect the two of those, like so, the midpoint would be here. And the center of mass would be there. So what we can see is the center of mass will have moved downward. The center of mass will have moved downward. But intuitively, it makes sense that the system itself is falling toward the Earth, even though there's this pulley mitigating things. So that's why it is this choice. Center of mass is moving downward.